Alright, I'm going to talk about the PA3 and PA4 model converter and viewer. I'm just going to go through some of the points, some of the things that I did, and I'm going to demonstrate converting the files and having them show up in the viewer, the game engine. So this is the code for the converter. The point is to take existing FBX and TJ files, extract the vertex and trilist data, get any texture data, and package it all into an SPU that can be extracted in the game engine viewer from a single file. So here I assert that I have an input argument in FBX at least, and an output SPU. At this point I assume that from all the previous code that the vertex and trilist data has already been gotten. So here I copy over the vertex data, and here I'll instantiate the file names that I'm going to use as commands for vodka and LIU. So I'm going to instantiate a file name for the bin. I'm going to instantiate the output file name, the .blo file, and then I'm going to open the bin files here and here. I'm going to write the data from the vertex and the trilists that I instantiate over here. I'm going to write that to each respective file, and I'm going to close them. And then I'm going to concatenate the strings together to make a vodka command, and then I'm going to run them both here. So at this point I should have two .blo files. The way I set up my converter, if the include texture parameter is included after the output file name up here, then after this you can add as many .tj file names as you want, and it'll package all of them into the same SPU. So that's what this does. It first checks to see that you have include texture and that you have at least one file name after it, and then for as many file names as you have, it'll get the path name, it'll concatenate a vodka command line string, and then it'll run that. At this point all of the packages will be .blos, and then here I'll concatenate together the command for the LIU. So the final output file that you specify in the converter, the SPU, that's what it'll create, and this is what it'll run, and then I'll delete any intermediate files. So I copied over the .exe, and I can run this as a standalone, and that's what I'll do now. So because of where my PA3 was originally stored, which is here, it's stored in my Google Drive folder, and it has a space in the name, and I can't change that, and that caused some issues actually running the converter. So what I did was I copied out the code into a folder here where I can run it from. So yeah, here I have this libfbx sdk.dll file, the model converter exe. Both of those are needed to run, and then I have the vodka and LIU exe files as well, and then I have all the respective FBX and TJ files that I would need, that I'm going to convert. And then this run is a batch file which I can open, and it essentially runs the converter for all five of these models. So I'll go ahead and do that. So when I was working on this in the converter, I commented out a bunch of print statements, but I missed a couple, which is why there's this sort of mumbled, like messed up output, but it doesn't mess with the actual conversion process. So here I now have 5 SPU models which hold all the information. I can copy all of these, and I can move them over to my engine. So I already have SPU models here, but if I try to paste them, it'll say that it's going to replace them. So I'll just do that to make sure I have the most updated ones, and then I'll open up the engine. So here is my engine code. Just jumping into a model, for example, the Astro Boy model, I followed the similar procedure as previous models. I instantiate pointers to arrays for the vertex and trilist data. I have an unsigned char pointer eat buffer, a chunk size, and a status. And what I did was I brought in the eat command from the archiver to be able to extract certain chunk types. So what I do is I'll first extract the verts, the trilist, the textures. I'll get all the data. For the texture, I'll open up TJ file and add the texture to the texture manager, and then I'll go ahead and add in all the vertex and trilist data to the GL commands as necessary. And then here I have the code for instantiating a bounding sphere data. I didn't move this to the converter yet, but I will. But for now, it's here, where once the vertex data is all here, I will get the reference sphere data from the model vertices, and then I'll delete the pverts array, and I'll go ahead with that. So then here in the game CPP, I instantiate all of these models using these SPU file names. I have the sphere model as well, and then I proceed to add game objects as usual. So just to make sure that I'm talking about everything correctly, going into the viewer here, yeah, so I'll show that I have 5 models and 2 instances. The one thing I wasn't able to figure out just yet is texture changing for specific models. I can texture swap between different models, but I have yet to implement doing it for specific models. So for example, for the Warbear, only swapping between the 2 textures that it has. I'll show the bounding spheres toggling and displaying. I have the default texture as well, and I just showed that the model data is gotten from the single SPU file. So now I'll go ahead and run this. So here is my model. Here are my models. As you can see here, I have a Warbear with a polar bear texture. I have these polar bear wireframes. I have 2 different space frigates. I have 2 buggy models. I also have a space frigate here with the default texture. I have Astro Boy with the texture, and Astro Boy as a wireframe. And then I have a rabbit and a rabbit as a wireframe here. And then this is just a regular sphere wireframe. So I can move around, I can go in and out. Oh, and I also have the camera model as well. So I can do this. I can switch back to my camera model at angle. I can swap between the textures. It'll swap it for all of them. And then here is where I can toggle the bounding spheres on or off, and you can see they follow the object. I set it so that if I don't want a bounding sphere, for example, I don't want to have a bounding sphere for the bounding sphere, I don't have to. So here you can see that the wireframes are following the objects and updating their location. They have the correct size. And I can toggle them on or off. So yeah, this is pretty much everything that I wanted to talk about. Just wanted to show what I have. Obviously I'm going to keep working on it, and then for the animation stuff, I'm definitely going to want to improve on this as well. So this is my converter and viewer.